So this is our warm-up for today. We're starting topic 3. It is your last topic. So this is the last new thing we are learning. Friday and Monday will be the last new things. Then we're going to prepare for your last test, and then it's final. Okay, so you got to hold on for me for a few more weeks. So let's start with this fraction, and I'm going to simplify. If I look at the numerator, what do I see I can do? Take out a GCF. What can both of these 2 and a 6 be divided by? 2. What will be left over? X plus 3. This will go faster. You answer my questions. The bottom or the denominator, what can I do? An eye chart. Very good. With my negative 15 at the top and my negative 2 at the bottom. 1 and 15, 3 and 5. How do I get negative 2? And negative 5. So I'll have x plus 3 and x minus 5. What do you notice can happen? What can cancel? The x plus 3s can cancel. Very good. So what would my final answer be? 2 over x minus 5. Now I have a question. This was a huge mistake on that quiz. What if this was also an x plus 3 instead? Could I cancel all 3 of them? No. Okay. I can only cancel one of the same on top and bottom. Only one can cancel if they are the same, not all 3. Okay. Speaking of quizzes, your corrections are due at 3 p.m. today in my classroom, stapled together, if you plan on turning them in. Okay. Let's go to problem number 2. It's a graph. It asks for an asymptote. Who remembers what an asymptote is? Logan? Very good. It's the line my graph can come very, very close to, but it never touches. It looks like it's touching, but if I zoom in, remember, it's hovering right above it. So I'm going to draw my asymptote there. How does an asymptote get written? What would that be? Y equals negative 4. Why? Because it's crossing the y-axis at negative 4. Very good. What is my x-intercept? About what?
About 5.
5.2. Don't put just 5 because it's not on the 5, right? 5.1, 5.2. I would take either one, but it better be written as a point or it's incorrect. What's my y-intercept going to be? Can it be negative 4?
No.
Why can it not be negative 4? It cannot touch that asymptote. So what's the best number that's right above negative 4? Negative 3.9. Very good. So 0, negative 3.9. Okay? My domain. Which way does domain go? Left to right. If I start at the left, what am I going to get to first? Negative infinity. And my graph is way up here, but I don't care that it's pointing up. What do I care that that graph is doing? Going right, which means, okay, positive infinity. What is negative infinity to positive infinity? There's 3 words you can say instead. All real numbers. You have to know that. Have to. So write it down if you need it. Negative infinity, positive infinity is all real numbers, and that's the symbol for it. It's like a letter R, but it has 2 lines in front first. Okay? All real numbers. My range, where's the bottom of this graph? Negative 4, but what do I know about it? It never touches, so what does that negative 4 get? A bracket or a parenthesis? Parenthesis, because it's not touching. Where's the top of my graph? Positive infinity. Very good. Okay. Why did I make you do this? Because the last topic we are studying are these 2 things put together. So we're going to be using equations and graphs to get a lot of information, okay? Today we will focus on graphs only. So, my Zoomers, you should be in a class pick right now for notes. It's in your chat. The code is LXV24R. That way, if you watch this later, you will know what it is. LXV24R is your class pick code. If you're in my classroom, you need this little half sheet of paper where our notes are going to happen today. So, here we go. I'm going to start sharing. Stop sharing real quick. Get all set up for this. Hold on, y'all. There's a lot of stuff you got to click. There we go. If you have a colored pen or pencil, you might want one. If you don't have one, Mr. Mattel can walk around with a crayon. We're out of colored pencils. So if you would like a crayon, just kind of put your hand up and he'll bring you one, okay? So here are our class notes. And if I were you at the very top, I would make sure that I know this is Unit 13, Topic 3, and it's called attributes. Remember, attributes are the characteristics or the descriptions, okay? All right, this is what is called a rational graph. A rational graph has two or more L-shaped graphs, okay? I tell you to toss one to Carson. Two or more L-shaped graphs. That's what a rational graph is, okay? So where I am going to start is I'm going to start at my vertical and horizontal asymptotes because you have to know those before we can get other information. So an asymptote is going to go between my two graphs. So for example, follow closely. I see a line right here between my two graphs. Does everybody see this? It looks like my graph is touching, but if I keep drawing it, it doesn't really touch it. Is that vertical or horizontal? That is vertical. So how would I write my vertical asymptote? Is it cutting the x-axis or the y-axis? X equals what number? 5, okay? Let's go find if I have a horizontal asymptote. Horizontal goes side to side. So I can see between my two graphs, there is a straight line right here for my horizontal asymptote. What axis does that line cross? The y-axis at what number? At 0. Very good. Questions so far? You have to find the asymptotes before you do anything else, okay? Get in the habit of doing that. Now let's go answer the other questions. So, x-intercept. Where on a graph is my x-intercept? On the x-axis. What else is on my x-axis in this problem? The asymptote. So can I have an x-intercept? So I would write none. I don't have one because my asymptote is there instead. My y-intercept touches my y-axis. Here's my y-axis right there. About what will that point be? Positive or negative? So about 0, negative 0.1. Negative 0.2 is fine as well, okay? This word, holes, this is brand new. Do you see a hole in my graph? That's this part right here, right? This is my hole, okay? All I care about for this hole is what is the x value. So a hole is always going to start with x equals. So if I were to put a point where that hole is, what would the x value be? So x equals 3. That's where my whole has to be, okay? Now we're going to do domain and range, and it can get tricky, but pay attention and answer my questions for me. Let's look at domain. Domain goes left to right, okay? Put your pencils down and watch real quick. If I come from the left side, I start at what? What is my graph doing? Negative infinity. Just this one graph right here, where does it stop at? Like if this didn't exist, my domain would be negative infinity to 5. Does everybody see that? Okay. I'm going to write it underneath. Negative infinity to 5 with parentheses, right? Because I can't touch that asymptote. Now, what if I just have this graph? What is my domain going to be? Where does it start? 5, and it goes all the way to what? Infinity. So that domain would be 5 to infinity. Now, instead of writing this out every single time, because it's going to become a lot in a little bit, I can change how I write it. I can say my graph goes all the way from negative infinity to positive infinity. What's that called? All real numbers. So my graph is all real numbers. But when I do my domain, what number can my domain not be on? 5. Why can it not be on 5? Because my asymptote is right there. So I'm going to say it's all real numbers, but x cannot equal 5. This problem is special because it also cannot equal another number. Does anybody know what number it also cannot equal? Why 0? But I don't care about that. That has nothing to do with going this way, right? Okay. If I come here, what do I get to that my graph doesn't exist at? That whole, which is 3. So x cannot equal 3. And we're going to take some notes really quick. X cannot equal 5 is because I have an asymptote there. X cannot equal 3 is because I have a whole there. Okay? So it's every number in the world, but it can't be my asymptote. It can't be my whole. Okay? Let's go do my range. So if I start at the bottom, I'm going to have negative infinity. And just the bottom graph, where does my bottom graph start at? Stop that, excuse me. At 0. And then if I look at my second graph, it starts at 0 and it goes all the way to infinity. So how could I write this? Negative infinity to positive infinity is every number in the world, all real numbers. But what do I know when I'm moving up and down? What can I not stop at? At 0. Y cannot equal 0. Why can y not equal 0? Because that is my asymptote. Okay. Now, will every graph have a whole? No. Will every graph have 2 asymptotes? No. Okay, so you really have to pay attention to your graphs and see what you do and don't have on there. So today we are only practicing the graphs. On Monday, we will move on to the equations. So this packet that you have is stapled backwards. Just flip over and start here, and we are going to work backwards. So this packet that you have is backwards. If you are on Zoom and you are in Class Kick, this packet starts on page 2. Page 1 was your notes. Page 2 is your work, okay? So I need everybody starting on these graphs. If you don't understand or you have a question, ask. There is an answer key at the 3 clusters of tables. So you'll just have to pass it up and down the table. Y'all do a problem or two, check your answers. Do a problem or two and check your answers, okay? Any questions? No questions?